little bit. Let's go this here. Let's try that again. So that's all of the different components I've installed in there. There's a computer engine command line interface. There's a whole bunch of stuff around the G-Cloud commands that I have, Cloud SQL tools, BigQuery tools, etc. Right? So let's say I wanted to spin up a new instance in here. All I have to do is G-Cloud compute instances. Let's go ahead and list what we have first. Oh, maybe I should do this at the top. Let's say G-Cloud compute instances. Did I type that right? List. Yeah, got it. So now what it's doing is basically going ahead and looking at all of the different instances I have running on my machine. So it says here's all my Mongo instance, my Kubernetes instances, etc., my Jenkins instance. And if I actually go back to my console, that's basically all of these instances I have here. So everything I can do from the web, I can easily run from the command line on the console as well, right? And we also have different concepts of creating networks. We have load balancers, etc. You can also have things like snapshots, where you take a snapshot of a disk and put that into storage, and then you can create a disk image out of that in the future if you want, and you can boot from that and so on. Right? So at its core, this is what the compute engine offering is all about. It's infrastructure as a service, and that you can spin it up in any way, shape, or form that you like. But the nice bit you can see here is, as I said before, I have instances in Asia, instances in US, instances in Asia here. Did I have anything in Europe? No, I didn't spin up one in Europe. Up there? No, that one I deleted that instance. So bottom line is, I can have these instances anywhere, right? So the interesting bit is, if I go, for example, go to this instance here, and once I'm in that instance, let's give it a couple of seconds. My file here is a little slow. Let's establish a connection. There you go, right? So if I'm on my demo machine, so if I did say ping, and let's see which one we want to ping. So this one is in, where is this one? This was in Asia, so let's pick somebody in the US. Let's say, let's pick this guy. Is there another machine I have in the US over here? No, I don't know. I don't have one. I just got this one here. So let's go to this machine. I'm a little lazy, so let's copy and paste. Copy. Where are you? Right, so if I go back here and just hit that, let's see it. Use it. It's not very clear over here. It's hard to see. See it. Why don't I just spin up one machine in Europe for you? It's probably easier that way. So let's go ahead and create a new instance. And let's say whatever on this one. Let's say this one is US Central A. And yeah, I'll do standard one. Just select an image. Let's say it's a Debian image. Go ahead and put that in your central link. So I'll hit create on that. So that machine is now a spun up a machine in the US. And let me go back to my window over here. And hopefully this resolution will work itself out. Yeah, I think we should do it 100% is, it's not too bad. Yeah, there you go, at 100%. Wait till that machine comes up. So where's our machine? Instance number 5 running on your Central 1A. So as you can see, this is a machine I just booted up. And when a machine is booting up, maybe I'll just show you this one also. You can actually get the serial console output of how that machine is actually booting out. All of the VM related serial console messages just come out on the serial. And you can grab for this or get the serial console output on the command line as well. So this machine is up and running now. So let me just go ahead and copy that and go back here. Let's do ping instance 5. So you can see that one machine is getting about 162 milliseconds ping time very consistently, and this machine is in Taiwan, and the other machine is in the US, and everything is just operating like it's one local network, right? And that's the advantage. You don't have to worry about doing these kind of things in a complicated distributed fashion, because we just take care of it automatically for you underneath the covers. So whether that machine is in Taiwan or is in the US, they just behave like they are part of one network, right? So let's leave that and let's get back to the slides here. Right, so that was a quick walkthrough. Now let's get to the more interesting stuff, right? So that I needed to do that so that you had a basics about what the Google Cloud Platform is before we get into this section, right? Google and containers it's a long history. Everything at Google, we have been running it inside containers, right? And we have been mostly using that for internal usage. We do a lot of work on containers basically to do things like resource isolation, predictability of those resources being available. We're able to do all kinds of tuning around batch and latency sensitive applications. And we're able to account for the resources we use internally as well. So internally, Google has been using containers for a long time. In fact, we launch about 2 billion containers every week, right? So from the time I started this talk in the last 15 minutes, maybe we have launched about 200 to 300,000 containers, right? So that's the scale at which Google has been using container technology internally, right? So this is not something new to us. This is basically our bread and butter, and we have been using that for a long time. In fact, we have been working and contributing a significant amount of work back to the Linux kernel, which all have translated into the containers work, right? I don't know, we did some work around limited isolation. In fact, C groups, which was kind of the basis for all of this getting kickstarted, was actually done by 2 Google engineers, right? It started out as, I think it was called process containers or something like that, but then the naming was changed into control groups because there was a lot of confusion about what that was all about. So back in 2006, that's what we started that. Then we released our own container stuff at LMCTFY. Anybody wants to tell me what that is? Yeah, go ahead.
Let me contain that for you.
Exactly. So it's let me contain that for you. There's a lot of funny acronyms that go around, but yeah, that's by far the funniest one I've seen. And then recently, I think there has been some work that's been going around to redesign C groups as well, and then namespaces were also introduced there, a bunch of processes which are completely isolated from each other and so on. So all of these is work that Google has done, and we have contributed that back. And I think C groups was kernel version 2.6 something, and I think namespaces is much more recent. So that's just to show you that, we are, as a company, we are really excited about containers. Because personally, I think containers is going to be the future of how things get deployed. And you guys are all the right me to meet them. So yeah, so that one is let me contain that for you. So it's basically integration with Docker as well. The nice part is it basically separates policy from enforcement, and it also has both the programmable data and a command line interface as well. So So all of that is pretty nice stuff. If you want to grab that, just go to Google, github.com/google/lmctfy. Right? So how does the container stack actually work at Google, right? I mean, so there is two different aspects to it, right? One is this notion of a managed base operating system, right? And then there is a container manager for that node on top of that, right? And with just those two, you could do all of the regular stuff that you do with Docker, which is deploy stuff, move that into that location and so on. But we also do stuff which is beyond just that, right? We also have a cluster scheduler, right, which is aware of all of the resources that are available, and then can go ahead and schedule that container in a particular location where resources are available and so on. So it basically allows for work and tasks to be distributed across nodes, and you can basically specify the work based on your intention, right? I want to say you can declare all kinds of different things like what is the latency sensitivity of something. As you can imagine, there are processes that we run which are back-end log processing tasks, and there are front-end tasks which are user-facing and so on. And all of that can be handled quite gracefully by the container management, right? And I'll show you what we have done now is to basically release an open source implementation of that as well, called Kubernetes, and I'll show you a demonstration of that one as well, right? So that's a cluster manager on top of whatever the containers are, right? And both of them are, technologies that are required if you want to do large-scale stuff, right? And why do we do that, right? I mean, I don't think I need to preach to this crowd, but it's very, very useful to be able to say these things in a much more declarative fashion as opposed to having a very imperative approach of saying, deploy this container on this particular server, right? You can do that for sure. But it's much more flexible if you're able to say things like, run 100 copies of this container, and my required SLA, if you like, is the target of only 2 of those can be down at any one point in time, right?